Welcome back to Arxflix. Today, we're diving into a game-changing paper titled Deep Residual Learning for Image Recognition. This paper introduces an innovative residual learning framework that allows for the training of extremely deep neural networks more effectively than ever before. The paper starts by addressing the challenge of training deep neural networks, notably the issue of vanishing and exploding gradients. This remains a challenge despite advancements in network initialization and normalization techniques. The classic example here shows how a 56-layer plane network actually performs worse than a 20-layer one on the CEF-R10 dataset due to higher training error. As networks become deeper, a strange phenomenon called the degradation problem occurs. Beyond a certain point, increasing network depth leads to higher training errors rather than improved performance. Interestingly, this isn't due to overfitting, but rather an optimization issue. The question then arises, how do we solve this degradation problem? The solution proposed in this paper is residual learning. Instead of hoping each few stacked layers directly fit the desired mapping, the authors reformulate these layers to fit a residual mapping. Essentially, they let the network learn the difference, or residual, between the input and the desired output. Here, mathfx represents the residual function, and mathfx is the input. This simple but powerful reformulation makes optimization easier. The framework leverages shortcut connections, or identity mappings, that let the input bypass the layer operations, effectively making the network learn just the residual function mathfx. The authors demonstrate this concept with extensive experiments on popular datasets. They built various deep residual networks, or ResNets, scaling up to 152 layers, easily surpassing previous models in depth while maintaining efficient computation. For instance, on ImageNet, they constructed ResNets capable of outperforming plane networks significantly. The 152-layer ResNet, illustrated in this network architecture diagram, is not only deeper but also more computationally efficient than the VGG nets. The ResNets achieved groundbreaking results. An ensemble of these networks achieved an error rate of just 3.57% on the ImageNet test set, winning the first place in the ILS VARC 2015 classification competition. This graph shows the training and validation errors for plane and residual networks on ImageNet. Notice how ResNets maintain lower training and validation errors across the board. The practical implications of this work are enormous. Residual networks are not only optimal for image recognition tasks, but also generalize well to other visual recognition tasks like object detection and segmentation. The analysis reveals that residual functions have smaller response magnitudes compared to non-residual ones, highlighting the underlying efficiency of this approach. On top of that, the paper delves into various experiments, including those on CEF-R10. These experiments underline how ResNets manage to overcome optimization difficulties and achieve high accuracy gains, even with extremely deep architectures. One fascinating case is the CEF-R10 experiment. Here, even a 1202-layer ResN was trained, achieving competitive results while maintaining lower training errors. This figure shows how the residual networks maintain lower error rates and efficient learning dynamics across various depths on the CEF-R10 dataset. In conclusion, deep residual learning for image recognition has fundamentally changed the landscape of deep learning. Its residual learning framework effectively addresses the degradation problem, allowing for the successful training of very deep networks. This approach has set a new benchmark in the field, demonstrating remarkable improvements in image recognition tasks. Thanks for watching. If you found this video helpful, make sure to subscribe for more research breakdowns. Until next time, keep pushing the boundaries of what's possible in AI. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.